Alright class, welcome to video 6.2, part 1. This is section 6.2 in physical science. Let's go ahead and check out our objectives. 1. To identify what information a chemical equation contains. 2. State the principles of conservation of mass. 3. Explain what a balanced chemical formula must show. And 4. Name 3 categories of chemical reactions. Okay, SRQs. Our lecture activities include the SRQs, page 201, numbers 1 through 3, and math practice. Don't forget the old math practice. Make sure that you have your book open, and this time we're starting on page 194, describing chemical reactions. I'd like you to also make sure that you have a piece of paper to take some notes on. This is a different piece of paper than last time. It has your name, the heading, and section 6-2 all over it. All right. Without further ado, it's time to get started with our video lecture. Now, we'll do the discovery activity maybe in class. Just go over this and read it, think about it. I'd like to point out that we have some key vocab words that you probably want to make sure that are on your notes. Chemical reaction, reactant, product, conservation of mass, open system, closed system, coefficient, synthesis, decomposition, and replacement. Woo! There's a lot of words there, but that's okay. Make sure that you write them down as you go so you don't get overwhelmed. Now, let's keep reading. You look at your cellular phone display and read the message, "You want to get pizza tonight?" You reply, "No, maybe TPM dot. See you later." I don't know what TPM means. This message is saying, "Do you want to get some pizza tonight?" And no, maybe tomorrow afternoon. Oh, TPM. Get it? See you later. Cellular phone messages use symbols and abbreviations to express ideas in shorter form. A type of shorthand is used in chemistry too. Hydrogen molecules react with oxygen molecules to form water molecules. It is a lengthy way to describe the reaction between hydrogen and oxygen, and writing it is slow. Instead, chemists often use the chemical equations in place of words. Okay, so just like you might write shorthand for your cell phones, scientists use chemical equations instead of words. Let's keep on moving to page 195, please. What are chemical equations? Now in your notes you just might write chemical equations and then underneath a little subtext. A chemical equation, vocab word, is a short, easy way to show a chemical reaction using symbols instead of words. Although chemical equations are shorter than sentences, they contain more information. Chemical equations use chemical formulas and other symbols instead of words to summarize a reaction. Formulas in an equation. Now, class, there's a difference between a chemical formula and a chemical equation. Okay? We're going to find out what that difference is. All chemical equations use formulas to represent the substances involved in the reaction. You may recall that a chemical formula is a combination of symbols that represent the elements in a compound. For example, CO with a little 2 is the formula for carbon dioxide. The formula tells you that this compound is made up of elements, carbon and oxygen, and each molecule has one carbon. Why one carbon? Because there's no number after C, just a letter, carbon atoms, and 2 oxygen atoms. Why 2? Because there are 2 oxygen atoms. Figure 7 lists formulas for other compounds that may be familiar to you. Okay, H2O for water, CO2 for carbon dioxide, C3H8 for protein, sugar. Oh, that's a big one. And rubbing alcohol, all kinds of them. Check them out as we go. Structure of an equation. All chemical equations have a common structure. A chemical equation tells you that the substance you start with in a reaction and the substances you get at the end, the substances you have at the beginning are called reactants. When a reaction is complete, you have new substances called the products. All right? Great vocab words. I want you to know, what is the difference between products and reactants? That sounds like a great quiz question, along with the definition above. The formulas for the reactants are written on the left. followed by an arrow. You read this arrow as yields. The formulas for the products are written to the right. When there are two or more reactants, they are separated by plus signs. In a similar way, plus signs... Oh, hi, Joe Kennedy. I used your book to make copies. Thanks for leaving it in the classroom. Plus signs are used to separate two or more products. Below is the general plan for a chemical equation. Reactants plus reactant yields product plus product. All right. The number of reactants and products can vary. Some reactions have only one reactant or product. Other reactions have 2 or 3 or more reactants or products. In Figure 8, you can see the equation for the reaction that occurs when limestone, CaCO3, calcium carbonate, is heated. Count the number of reactants and products and familiarize yourself with the parts of the equation. All right. Here's calcium carbonate. It looks like there's one calcium atom, and we have the carbonate ion, which has 1 carbon and 3 oxygen atoms. Yields, which means gives. Okay, so there's only one reactant. You get calcium oxide. That's a formula. All right. Calcium oxide and carbon dioxide. Check the subscript out that represents 2 oxygens, and this subscript represents 3 oxygens. Wait a minute, Mr. Worley. There are 2 products and 1 reactant. Doesn't it have to be balanced? No, it doesn't. In this case, the only thing that's happening is you're taking calcium carbonate, limestone, adding heat or fire or whatever, and you're coming up with this formula. All right, nice. Please move on to video number 2.